Welcome to another college math video. In this video, we're going to continue our journey with sets, but here we're going to focus a little bit more on if we had lots of information. So sometimes it's important to be able to individually place all of our elements within sets, but sometimes we don't care what those specific elements are. We just care how many elements fell into that specific region. So this video is all about dealing with those larger quantities of information and kind of coming at sets from a different angle. So there's only one objective in this video, use Venn diagrams to solve problems. And like I said, it's kind of the backwards version where we're coming in from a different angle and dealing with a different type of information. So our first example, given the information, build a Venn diagram. The following are results of a survey done on visitors to Caracas, which is a city in Venezuela, to some of their famous places. So two in particular, El Obelisco and El Avila. For our purposes, this data is made up. Those places are real, but this was just to help us see, this example is just to help us see how this could all work. All right, so the information we're given, there were 160 people surveyed, and then information from the survey, 132 people visited El Obelisco, 106 people visited El Avila, and 82 people visited both. So here are the questions that we want to answer. How many went to only El Obelisco? When we look at that number of 132, it only represents all the people that went there. So of those people, some went to El Avila and some did not. How do we know who those people were? Second question, similar. How many visited only El Avila? Again, of that number of 106, some did and some did not go to El Obelisco. And then how many didn't go to either famous place? How can we figure out that based on this number of 160? It's pretty simple, but it's not quite as simple as just kind of picking one of those numbers. Okay, so let's do the Venn diagram first. Let's go with white. Within this Venn diagram, we have two sets. The two sets in this case are people that went to El Obelisco and people that went to El Avila. And obviously, some went to both. So we'll call this set O and set A. So think about how many different areas there are in this picture for us to fill in. Clearly 3, that's usually the first answer I hear. You could have someone that only went to El Obelisco. You could have someone that went to both locations. You could have someone that only went to El Avila. But there's a fourth location outside, still in the universe, but not in the circles. You could have a person that didn't go to either place, that participated in the survey. So we have 4 areas to fill in. I want to know how many people fall in each one of these 4 regions. And it's tempting to look at those 4 numbers and say, hey, I just fill in each of the 4 numbers into a location. It's not quite that simple, but it's not too difficult. So where do we start? The first thing we know, 160 total. So we know 160 total have to be in this universe. How do we partition them up? 132 visited El Obelisco, so there are 132 in this full circle, 106 in El Avila, and 82 in both. So where can we start? My suggestion will always be to start from the bottom with problems like these. We can definitely fill in how many people went to both of them. We have this information. So fill this in. 82 went to both. First piece of information used. It's the only one we'll be able to simply fill in. But this helps us. Remember, that 82 is not an element 82. It's 82 people in that list. We don't necessarily care who they were, what exactly their names were. We just know there were 82 of them. So let's go up the list. The next thing we know is 106 people visited El Avila. So we have the circle, El Avila. There have to be 106 people in this circle. Well, part of the circle is already filled in with 82. So how do you think we find out how many are in the other region? Subtract. It's as simple as that. So to get this region, we take the 106 and subtract out the amount that have already been accounted for, 82. When we subtract there, we get 24. And that 24 represents people that only went to El Avila. 106 total went to El Avila. 82 of them also went to El Obelisco. 24 of them only went to El Avila. So we can answer that question right now. 24. All right, that piece of information is used. Let's go to the next one. 132 people visited El Obelisco. So here's the circle for El Obelisco. There have to be 132 inside this circle. 82 is already taken up, so what the remaining piece have to be? 132 minus that 82 we've already counted. So there are 50 inside this piece, inside this region. So 50 went to only El Obelisco. Still have 132 total, but 50 of them only went to El Obelisco. 82 did both. So we can answer that one. Used. The last question is how many people didn't go to either famous place? We still don't have that filled in on our picture, but we have one more piece of information to use. We know that 160 people were surveyed total. So there have to be 160 people inside this rectangle. Well, some chunks are already taken up. Those people have already been accounted for. So how do you think we figure out who goes on the outside? Again, subtract. We can add up the 50 and the 82 and the 24 to know how many are already accounted for. And that would be 56. The total amount in the picture is 160, so we take out the number that have already been accounted for, and we get 4. So there are 160 people in here. 50 went to only El Obelisco, 82 did both, 24 did only El Avila, and finally 4 of those 160 surveyed didn't go to either location. So you can sort of picture something like this. Like I said, we're a little bit more zoomed out on the Venn diagram now. It's sort of like when you look at your phone, if you were to type in gas station. When you type that in, if you're zoomed in really close, you're going to see a bubble for Shell and Exxon and this gas station, and you'll know specifically exactly what they are. But if you zoomed out a little bit more, it might start to give you bubbles where it says there's 24 in this region, 64 in this region, 55 over here. That's what we're doing. We're zoomed out. We don't care exactly which gas stations they are. We just care how many there are in a specific region. So that's kind of what this picture entails. So we don't have the list of items. We just know how many fall there. All right, so this is an example with 2 sets. Let's take a look at if there are 3 sets. So I want you to give this a shot as a practice problem first. Let me talk you through it a little bit. You're going to do the same thing using the Venn diagram. Fill in the number of amusement parks that fit in each zone on the Venn diagram, and then answer the questions. The questions are on the next slide. So this is all the information. 85 total amusement parks surveyed. 24 of them had a hotel. 55 had water rides. 38 had a wave pool. 13 had hotel, on-site, and water rides. That doesn't mean they're separate from those. It's still part of that full number of 24 and 55. 10 had a hotel on site and a wave pool. 19 had water rides and a wave pool, and 7 had all 3 features. So draw the Venn diagram. There have to be 3 sets here, the 3 of them being hotel, water ride, and wave pool. And then attempt to answer those questions. So give it a shot first on your own, and then we'll go through it together. All right, so let's see if we're on the same page. I think I'm going to draw the picture on this page. There's a little bit more room, and then we can read the data from here. So we want a pretty large picture, and within that we have 3 sets. The 3 sets being hotel. Let's go with R for water ride and P for wave pool. All right, so from our data, start from the bottom and work your way up. The first thing we know, or the last piece of information given, is that 7 had all 3 features. So 85 total have to go in this picture. We got to partition them into all little regions. 7 had all 3. That's the easiest one to fill in. Right in the middle where they overlap, all 7 fit right there. The next piece of information going up is that 19 had water rides and a wave pool. So here's water ride, here's wave pool, here's where they overlap. there are 19 amusement parks inside this little region. 7 are already accounted for, so we subtract to get how many are in this other region. 19 minus the 7 gives us 12. Okay, let's work our way up. Then 10 had a hotel on site and a wave pool. So here's hotel, here's wave pool. There are 10 in this overlap. 7 are already accounted for. So we subtract and we get 3 in this little region. So of the 10, 7 had water rides, 3 did not. But it's still 10 that had hotel and wave pool. Okay, next piece of information moving up. 13 had a hotel on site and wave pool and water ride. My mistake. So here's hotel, here's water ride. There are 13 inside this overlap. So again, we've already counted the 7, leaving us 6 in this piece. So where it gets a little trickier, we move up to the next piece of information. 38 had a wave pool. So this entire circle represents wave pool. There are 38 different amusement parks listed here. So we have a region that also has a hotel, a different region that also has a water ride, and then a region that has both hotel and water ride. So 38 total in here, we have to subtract out all 3 of those different regions. Minus 3, minus 7, minus 12. Wave pool, we get 16. Work our way up further. 55 had water rides. So there are 55 in this circle. Take out the 6, the 7, and the 12 that have already been accounted for in this circle. And we get 30. Then for hotels, we have a total of 24. Subtract out the pieces that have already been accounted for, the 6, the 7, and the 3, and we get 8. Whoops. And don't think you're done. There's one more thing to fill in. We still haven't dealt with that last piece of information, which is that 85 total amusement parks were surveyed. This isn't all 85. So to find that, we take the 85, subtract out everything that's already been accounted for, and we get the number of people or amusement parks on the outside. 85. And you can't just take any of the numbers from the original data. It's all have to, oh my gosh, it all has to be the picture, information from the picture. So the 6, the 8, the 30, the 3, the 7, the 12, the 16, and we get 3. So 3 on the outside. All right. Then to the questions. Now that we've filled in the picture, this is the most complicated part, then we're just reading that picture. So how many had only a hotel? So here's hotel, but these all also have something else. Only a hotel is 8. How many had a wave pool but no hotel and no water ride? So here's wave pool, but no hotel, so take those out. And no water ride, take them out. So it's just 16. This is another way of saying only a wave pool. The next one, how many had a wave pool or a water ride? Wave pool, water ride. Remember, in the world of sets, the word or means this, that, or both of them. You would be happy with a car with heat. You'd be happy with a car with air conditioning. You would definitely take a car that had both of them. So or in our world means everything in both. So to figure out this one, we add up all those numbers. We have 6 plus 30 plus 7 plus 12 plus 3 plus 16, and we get 74. Some of those 74 had both, some only had one, some only had the other, some also had a hotel. We didn't really care about that, but we certainly have some that also have a hotel. The next question, how many had none of the features? This would be our number on the outside, 3. And then how many had exactly 2 of the features? So this region in the middle means it had all 3. The 16, the 30, and the 8 means it only had one. The number on the outside had none of them. So where you see just two circles overlapping is where you have two of the features. So the 12, the 6, the 3. We get 21. So again, this is just a different way to deal with the information. To kind of sum this video up, in the real world, you really may not, you're going to be dealing with large amounts of information, and you really probably aren't going to care about which ones specifically were the case. For this example, for the last one, you can kind of imagine if you were doing a search. If you're trying to plan a trip with friends or with family, everyone has different wants. Some people want a hotel, some want water rides, some want wave pool. And so you would search and kind of figure out which ones had all three, what was in your budget. There'd be a lot of things you'd look at. But when you go online and you do a search and you check the boxes that say, I want this, this, and this, it's comparing all these things and only pulling the stuff that comes from the region that you've said is important to you, or from the regions you say, I want at least two of these three things. It says, okay, you can have these 12, these 6, or these 3 from our last example. So like I said, this section is all about looking at the data from a bigger perspective, really just dealing with the quantity, not necessarily the specific information, and then being able to assess important parts of the Venn diagram, things that might be important to you. I'll see you soon for another video.